A very good day to respective lecturer Madam Jasmine and my fellow friends. I am Neha Surendran Kumar. My metric number is 23 DLS 21F2004. I am from DLS 1B. Today I will be delivering an oral presentation entitled Nanotechnology. Thank you in advance for being all ears. Nanoscience and nanotechnology involve being able to see and control atoms and molecules on a very small scale. Everything on earth is made up of atoms, including the clothes we wear, the food we eat, and then the buildings and houses we live in, and our own bodies. But you can see an atom with your own eyes because it's too small. Based on my slide, let me explain what is the background of nanotechnology, which is the concept and the ideas of such technology have been introduced by a physicist called Richard Feynman at California Institute of Technology. He described this process through the molecules and atoms which can be manipulated, controlled of ultra precision. Professor Norio Taniguchi combine this word called nanotechnology in developing tools called like scanning tunneling microscope and atomic force microscope, which helps a lot in the analysis of the particles in nanoscale. Not only that, nanotechnology is also like the nanomaterials which possess high strength and lightweight and have a great chemical reactivity in comparison to bulk materials. Nanotechnology and nanoscience deal with monitoring the behavior and observing each of the individual molecules and atoms. I'm going to talk about three types of nanotechnology, which are nanomedicine, nanoelectronic, and nanoengineering. I'll talk about nanoengineering as my first point. Based on the types of nanotechnology classified in the way of handling a technology, manipulates the matter to increase the transistor, and the microprocessor is known as nanoengineering. Examples like carbon nanotubes, nanocomposites, and quantum dots. My next point will be about nanomedicine, which is the technology utilized in the manufacturing of the field in pharmaceuticals is known as nanomedicine. Examples will be on the slide. And continuing with the fabrications of electronic devices is understood as nanoelectronics. Examples: solar cells and supercapacitors are areas where nanoelectronic is playing a major role in energy generation and storage. I will be continuing with my second point, which is advantages and disadvantages of nanotechnology. I will be talking about advantages first. The advantages of nanotechnology is used to create materials that are unique, stronger, durable, and cheaper. Like solar panels, example, it promotes renewable energy and new ways to obtain and to store the energy, which is cheaper and more efficient. My another point would be cleaning of pollution, which neutralizes the water contaminants which damage human health or ecosystem by utilizing such technology like carbon filters and many more. The disadvantages of nanotechnology: the usage of this technology can cause issues related to health and safety which cause severe damage to humans' body. Example like the productions of nano weapons and smart bullets. And other disadvantages are the massive production which leads to the loss of employment in the sectors of farming and manufacturing in changes of production processes. I will continue with my third point, which is applications of nanotechnology. There are different areas where this nanotechnology is implemented. Some of the major areas are like nanotechnology, industrial industrial applications and nanoelectronics. I will start with applications of nanotechnology. Application of nanotechnology means generation of steam from the sunlight, which the concentration of the sunlight on the nanoparticles results in the production of steam that is highly efficient in the terms of energy. This solar steam device is utilized in various developing countries without the interference of electricity for the purifications of water, and it also produces highly efficient light bulbs that are shatterproof as well as twice efficient in comparison to fluorescent bulbs. I will continue with industrial applications of nanotechnology, which is used in various industries such as food, agriculture, consumer, electronics, aerospace, and many more. Nanofood describes food that has been cultivated, produced, protected, processed, or packaged using nanotechnology techniques or tools, or which manufacture nanomaterials that have been added. The utilizations of nanotechnology in the food industry has various applications, like change of characteristic of food. And then I will continue with my second point. In the field of agriculture, precision farming is carried out by using nanotechnology. What is precision farming? An approach to farm management that uses information technology to ensure that crops and soil receive exactly what they need. And then lastly, I will talk about nanoelectronics. Microelectronics and nanoelectronics are subfields of electronics in which the nominal feature size of electronic components are between 100 and 0.1 meters in magnitude, or 100 nanometers or smaller than that. Nanoelectronics actually refers to the use of nanotechnology, like in electronic components, like set of device and materials with a common characteristic that they are so small and interatomic interaction. Microelectronic has certain disadvantages in terms of an increase in physical size as well as an increase in the cost of production. This can be overcome by using nanotechnology in electronics. Nanoelectronics allows more transistors to be accommodated in a single chip, which the usage of nanotechnology paved the way for increment in the processing, which speeds in computers by decreasing the cost of it. The presence of nanotubes made of carbon on the plastic sheet or glass allows the manufacturers to design a display with a clear and extremely thin conductive panel. Further, it provides huge memory storage application in electronics. Thank you. I will be summarizing or concluding what is nanotechnology. Nanotechnology has an impactful and bright future in various fields of applications. The compactness of the size is considered to be a great advantage of using this technology. There will be a predicted tremendous growth in the economy due to the involvement of technology. What can we learn? What are the values that we can learn from using nanotechnology is we can save the environment. How we can save the environment? By protecting, keeping raw materials, water, save the water by reducing greenhouses, gas, and then waste, and also help fight disease. How we help fight disease? Example, now for COVID, we can find medicine for the disease to cure the disease, and we also can use by using nanotechnology. We can create a lot of efficient products which will be helpful or useful for everyone in the future. Thank you. Before ending my oral presentation, I would like to ask two questions. Question 1 is examples of nanotechnology which can be found in households. Question 2, what is nanotechnology used in everyday life? Thank you.
Today, we are going to talk about nanotechnology. When we say something is nano, we mean it is very small. The size of 1 nanometer is 1 billionth of a meter, which is about 100,000 times smaller than the width of a human hair. Making new things at this incredibly small scale is called nanotechnology, and it's one of the most exciting and fast-moving areas of science today. Some nanomaterials are naturally occurring. You can find them everywhere, in volcanic ash, ocean spray, fine sand and dust. Naturally occurring nanostructures are also present in plants and animals. For example, nanostructures in insect eyes ensure an anti-reflection and water-repelling effect, so they can fly safely. Nowadays, scientists can create nanostructures themselves. By rearranging the atoms of an object, they can make new nanomaterial with new properties, for example, that are stronger, lighter, or different in color. The properties change also according to their size, and this is the magic of the technology. In the food area, researchers are working with nanotechnologies to create novel products that may be of benefit to health and diet. For example, nanosilver has antibacterial properties that can be used in food contact material, such as cutting boards. In food supplements, nano-sized carriers increase absorption of nutrients. Nanosensors can be incorporated into packaging to monitor the quality and shelf life of food from manufacturers to consumers. It can also make food ingredients tastier or healthier. Carving up a grain of salt into small nano-sized grains increases its surface area significantly. This means that your food needs far less salt to be equally tasty. This is good news for those who like crackers but are worried about their blood pressure. We need to make sure that food nanotechnologies do not cause harm to consumers. This is why in the EU, engineered nanomaterials in food require a safety assessment. Their specific properties need to be taken into account when assessing impact on human health and the environment. And this is where EFSA comes in. Over the coming years, nanotechnology will touch the lives of all of us. Like many scientific advances, it brings uncertainty and potential risks. It is up to scientists, business and governments to make it work.